Hi, this is Rick for EDU Mobile. Now we have a demo on dictionaries, or as I have called it, doing some stuff with dictionaries. Here we go. We set up a dictionary here, a literal dictionary. We don't have to say dictionary is of type string int because we see and Swift infers that that's the type. So elements, and our periodic table only has the first three elements. Hydrogen 1, helium 2, lithium 3. So for symbol, number, in elements, this is how we use a for in to iterate through the dictionary. Print line, the element symbol, has number, protons. What are we doing? Print line, the element key, has value, protons. That's what we're really doing here. Next, we printed out the count. So let's look at that. We see that the element lithium has 3 protons, the element hydrogen has 1, the element helium has 2. If we run this 100 different times, we'll probably get this same ordering. But the order of elements in a dictionary, any dictionary, is not, dictionaries aren't ordered sets. So we may not get this order every time, and we certainly can't count on any particular order in a dictionary. So now we've also printed out there are count elements in the dictionary. And here we see there are 3 elements in the dictionary, and this is correct. So now let's make an empty dictionary. This is something I didn't talk about in the discussion, but sometimes it's important to be able to make an empty dictionary. If we have an empty dictionary, we need to supply what that dictionary's type is. And so we can make an empty dictionary by using a dictionary's initializer. It's empty, but the types have to be there. This shows that dictionary is a generic. What do I want? A dictionary containing integers as keys and strings as values. Now we can add a couple of ints here. We can add 42, 6, and 7. And then the key for 42, integer 42, goes to the value spelled out 42, and so on and so forth. Now notice what happens when the values are added. They are added as optionals. So if we print line int names 42 divided by int names 6 equals int names 42 divided by 6, which should give us 7, something that doesn't look weird. It does look kind of weird, but you can do it. It's fine. We have defined this. We get back optional 42 divided by optional 6 equals optional 7. Knowing that, we can explicitly unwrap them with the bang operator, and we can get 42 divided by 6 equals 7, which is what we want. Now we can remove all elements from an array, or I'm sorry, from a dictionary, using this syntax. Square bracket, colon, square bracket. This removes all the elements in a dictionary. We can also use remove at index, or remove at key, to remove an element from a dictionary. So now we can also use anything for the set of a dictionary's values. For instance, we can use an array as the values for a dictionary. So the type of this dictionary is dictionary with the keys of strings and the values as arrays of strings. It is inferred from the type, or from the literal that we've supplied. So counting, we've said is a dictionary, and we've done it in 3 different languages from 1 to 5. The key English refers to the array string 1, 2, 3, 4, and 5. Spanish to the array 1, 2, 3, 4, and 5. French 1, 2, 3, 4, and 5. So now we can go through and iterate through the dictionary, the key and the value, and then go through the values and iterate through them as iterating through an array, and then print the number. And then, just to keep things separate, we issue a print after each initial 4, and we get 1, 2, 3, 4, 5, and then we're into the Spanish 1, 2, 3, 4, 5, and then we're into the French 1, 2, 3, 4, 5. Okay. The value of a dictionary, as I already inferred, can be of any type. We could use a tuple, for example. We can say animals, the key is elephant, chicken, and snake, and the value have their number of legs and their family or their type. So an elephant has 4 legs and is a mammal. A chicken has 2 legs and is a bird. A snake has no legs and is a reptile. So we can see that that can be iterated through in the same way. Animal, data. Animal being the key, data being the value. And then out of data, we can get data.type and data.legs because those are named in the tuple. If we did not name them in the tuple, we would have to say data.1 and data.0 to get those same values out. So naming elements in a tuple is pretty nice. So when we do that, we see name elephant, type mammal, legs 4, name chicken, type bird, legs 2, name snake, type creepy or reptile, legs 0. And that's it. So that's really all there is to dictionaries. They are unordered collection types where the keys are all of one type and the values are all of another type, even if that other type is a composite or a collection type. So we can have dictionaries where the values are of any type, classes, structures, enumerations, anything we want. But the keys have to be hashable and they need to be unique. Thank you very much.